Welcome to Susie Tran channel. I am a representative voice of Susie Tran.
And I am a representative voice of Valent.
We've got a stack of presentation slides today from Susie's Build with AI talk at GDG Melbourne that give us a really practical look at integrating Google's Vertex AI.
Yes, specifically models like Gemini and Imagen directly into Firebase projects, especially if you're building with Flutter.
Exactly. It's interesting because it connects these two major platforms people are already using, right? Firebase for the backend, Flutter for the apps.
And now you get this sort of native connection to some pretty powerful AI via Vertex AI. It, simplifies things quite a bit.
Right. So our mission here is to walk you through what these slides actually show about making that connection happen.
We'll look at the setup, the different AI models they mentioned, how you actually talk to them from your Flutter code.
And the demo results, which are always key, what actually worked.
Definitely. And we should say up front, the slides assume some existing knowledge.
Yeah, they mention you kind of need to be comfortable with the Flutter SDK, the Firebase console,
command line tools, Firebase CLI, Flutterfire CLI, and crucially, already have Firebase set up in your Flutter project.
Right. Think of those as the prerequisites before you layer on the AI.
Exactly. It's building on that foundation.
Okay, ready to see what's involved?
Let's dive in.
All right. So getting set up starts in the Firebase console, according to the slides. What's the very first step there?
Well, you need to find the new AI section. It's actually labeled Vertex AI.
Ah, okay. And the slides highlight it's marked as new.
So it's clearly a recent addition to the console.
New woo definitely catches the eye. So you navigate there, then what? What are the key actions inside that section?
Two main things shown. First, and this is important, you have to upgrade your Firebase billing plan.
Right, not usually free tier stuff.
No, Vertex AI generally needs a paid plan like Blaze. Second, you need to enable the necessary APIs in your project settings.
Okay, that basically, flicks the switch, allowing your project to talk to the Vertex AI services.
Got it.
Upgrade the plan, enable APIs. That handles the Firebase backend side. What about the app, the Flutter side?
On the Flutter side, it's a pretty standard package management. The slides specify the package name.
Firebase AI.
Okay, and you just run Flutter pub add Firebase AI in your terminal.
Simple enough. Flutter pub add.
Yep, that pulls in the SDK you need to actually write the Dart code to interact with Vertex AI through Firebase.
Okay, so setup seems fairly straightforward if you're familiar with Firebase and Flutter already. Once that SDK's in, what models can you actually use? The slides listed a few.
They listed 3 types available through this specific integration. First, the standard generative model.
Right, for text and chat.
Exactly. And there's the image model, which is for generating images.
Okay.
And finally, something called the live generative model.
Live generative. And I notice asterisks next to image and live generative on the slides. What's that about?
Oh yeah, good catch. That asterisk means those two, image and live generative, are considered experimental within this Firebase integration, at least when these slides were made.
Experimental. Okay, good to know. So manage expectations there.
Right. And the slides also pointed to a Google Docs link if you want the full, exhaustive list of all Vertex AI models, not just the ones in this specific Firebase SDK yet.
Makes sense. Okay, let's dig into these one by one. Starting with the generative model. Seems like the most common one, maybe? How do you get that one going in Flutter?
Yeah, the code snippet shows a familiar pattern. You use Firebase AI.VertexAI.generative model.
Chain and calls.
Exactly. Access the service, then the specific model type. You have to tell it which generative model you want. The example uses Gemini 2.0 Flash.
Flash sounds speedy.
It implies that, yeah. And interestingly, right at initialization, you can provide an optional system instruction.
Oh, like a starting prompt or persona?
Precisely. You can set the stage for the AI's behavior before the user even says anything. Very useful.
Nice. So you've got the model instance, the slides slides then show two main ways to interact with it.
Correct. You can use a chat session, or you can do single content requests.
Okay, what's the difference?
A chat session you start with model.startChat is built for back and forth conversations. It automatically handles the history, the context.
Ah, so you don't have to manually track the conversation turns.
Exactly. Whereas single content using model generate content is more for like one-off questions or prompts where history doesn't matter.
Got it. Chat for dialogues, single content for isolated requests. How do you actually send the user's message or prompt?
So for the chat session, it's chatsession.sendMessage. For single content, it's model.generateContent. Both take a list of content objects.
And what's in a content object?
This is where it gets interesting, especially for multimodal stuff. A content object can contain text, obviously, using a text part,
Right.
but it can also contain other data like images, using an inline data part.
Oh, wow, okay.
Yeah, you provide the MIME type like image, JPEG, and the actual image data as bytes, so you can send text and images together in one go.
That's huge. Simplifies sending combined prompts a lot. What about getting the responses back? The slides mentioned streaming.
Yes, streaming is important for user experience, right?
Yeah.
Yeah, instead of waiting for the whole answer.
You get chunks as they come.
Exactly, it feels much more responsive. For chat session, you use chatsession.sendMessageStream. For single content, it's model.generateContentStream.
Okay.
And then you just listen to that stream in your Dart code to get the pieces as they arrive.
And you probably need to manage that subscription, cancel it if the user leaves the screen or something.
Absolutely, standard stream handling applies there. Clean up your listeners.
Cool. So, streaming for better UX. Now, the demo results for this generative model, what did the slides say? Did it work?
Yes, this one looks solid. The demo confirmed they were using version 2.0.0 of the Firebase AI package.
Okay.
The model was indeed Gemini 2.0 Flash, and crucially, it worked on Android, iOS, and web.
Cross-platform. Nice. Was it fast?
Very. The processing time noted was less than 1 second, so that Flash name seems appropriate.
Less than a second is great. What was the actual interaction they showed?
It was a basic text chat. The AI introduced itself something like, "I am Gemini, a large language model," listed some capabilities, generating images, providing date time, just a clear sign that the core text generation was up and running quickly across the board.
Excellent. So, the basic generative model seems like a go. What about the second one, Imagen, for images? How do you set that one up?
Similar initialization, Firebase AI.VertexAI.image model.
Yeah.
The slides used a placeholder for the model name, so you plug in the specific image model version you need.
Right.
But the interesting part shown was the image generation config you can pass in.
Ah, configuration options.
Things like add watermark false, setting the aspect ratio, they used landscape 16:9 in the example.
Okay, common aspect ratio.
Yeah, choosing the image format like PNG, and even setting the number of images you want back from a single prompt. The demo asked for 3.
So, decent control over the output format and quantity. How do you actually, ask it to draw something?
You call model.generateImages and pass in your text prompt. The result comes back as a list of image and inline image objects, and the key property there is byte space 64 encoded.
Ah, base 64 encoded image data.
Exactly, which is pretty standard for sending binary data over APIs. You can easily decode that in Flutter and display it using something like image.memory.
Makes sense. And reminding ourselves, this image model was marked experimental. How did the demo go?
It actually worked in the demo.
Oh, good.
Yeah, same SDK version, 2.0.0. The specific model was image 3.0 generate.002.
Okay.
And like the text model, it worked on Android, iOS, and web.
And the speed? Image generation usually takes longer.
It did. The slides noted a processing time of 3 seconds for the example they showed. Still pretty reasonable for generating an image from scratch.
3 seconds? Yeah, not bad at all. What did they ask it to generate?
The prompt was simple. Draw a green teddy bear.
Okay.
And the demo screenshot showed the resulting image, a green teddy bear displayed in the app.
Nice. A successful green teddy bear.
A win for the experimental feature. There was also a small note on the slide saying it was invoked via function call.
Function call. What might that imply?
It suggests that maybe under the hood, the Gemini model is coordinating this, recognizing the request needs an image, and then calling the image tool or function to actually do the generation. It's an interesting architectural hint.
Fascinating. Okay, so generative works well. Imagen, though experimental, but worked in the demo. That leaves the third one, live generative model. Sounds ambitious. How's that one initialized?
Again, similar pattern, live generative model, specifying a model name.
And using it, I mentioned a live session.
Yeah, this is where the interaction model seems quite different. It's clearly designed for more real-time continuous flows.
Okay.
You explicitly connect to create a live session using awaitModel.connect. And then you listen for responses coming back from the session using session.receive.listen.
So, establish a connection, then listen for incoming data. How do you send stuff to it?
You can send text using session.send, passing a content object like content.textPrompt. Interestingly, they showed a term complete false flag.
Maybe for sending partial inputs.
Could be, but the really unique parts were methods like session.send media chunks, which takes a list of inline data part that was marked experimental again,
Right.
and session.send media stream, which takes a stream of media chunks.
Whoa, send media stream. So you could potentially stream audio or video into the model.
That's exactly what it implies, designed for feeding continuous data, which opens up possibilities for real-time analysis or interaction.
That sounds incredibly powerful for future apps. But the big question, did this one work in the demo?
Oh, well, this is the key takeaway here. It did not work.
Oh, okay. No green teddy bear equivalent?
No, the slide showing the result for the live generative model basically showed an error.
An error. Did they show what the error was? Any clues?
Yes, they actually included the log output. It showed a WebSocket error.
WebSocket. Okay, so that persistent connection failed.
Exactly. The message was WebSocket closed, close code 1008, close reason. Requests from this Android client application, empty, are blocked.
Empty are blocked. That sounds like maybe an authentication or configuration issue, like the client wasn't identified correctly.
That's what it suggests. Maybe an issue with the app identifier or perhaps some back-end policy preventing the connection. And crucially, the slides added a note right there saying, quote, does not work yet.
Does not work yet. Okay, so it wasn't just a fluke in the demo. It was a known limitation at the time.
Precisely. It shows the API is there, the concept is there, but the actual implementation within this Firebase Flutter SDK wasn't functional yet.
Got it. So recapping the demo status based on these slides, generative model, good to go, fast, cross-platform, image model, marked experimental, but did work for image generation, live generative model, the idea is there for streaming, but it explicitly did not work yet.
That's a perfect summary of what the source material presented. It sets clear expectations for developers looking at this integration right now.
Yeah, even with one part not ready, it's still pretty exciting, isn't it? Just having Vertex AI accessible directly within Firebase for Flutter developers?
Oh, absolutely. It lowers the barrier significantly. You don't need to manage separate AI infrastructure or complex API keys necessarily. You leverage the Firebase connection you likely already have.
Right. Uses tools you're probably familiar with. Makes AI features much more portable for many app developers.
And for anyone wanting to really get into the weeds, the slides did mention the demo source code is available, right?
Yes, they provided a GitHub link and a QR code, so you can actually see how all these Firebase AI calls were implemented in the demo app itself.
That's super helpful for learning.
Okay, so we've unpacked these slides: the setup, the models, generative, image, live generative, the code patterns like chat sessions, multimodal input, streaming, and the all-important demo results.
Yeah, it gives a good snapshot of where this integration stands, what's working now, and what's still on the horizon, like that live streaming capability.
So let's think about that horizon for a second. That live generative model, even though it failed in the demo, the idea of streaming media directly into an AI model in real time, well, it's potentially transformative. When that does work reliably, what kinds of live AI-powered features do you imagine popping up in our everyday mobile and web apps? How might that change how we even interact with UIs if the app can understand and react to live audio or video streams? What does that future look like?
Yeah, I'll leave that question to the audience to answer.
Sure. And that marks the end of our video today. I hope this is helpful for the audience, and I hope to see many developers start using Vertex AI and Firebase to build their next AI application.
I hope so too. Now, thank you and goodbye.
Bye, all. And remember to subscribe for more videos to come.